All right, guys, we are looking at the probability of independent events. So we're looking at the probability of independent events. Okay, we've done a little bit of this yesterday, but we're just going to go over this in more detail. Shh, you should be writing this down. Should be focused up here. Okay. Probability of independent events questions. How is the probability of simple independent events determined? How is the probability of compound independent events determined? Okay, what do you think compound means? It means like more than one. Okay, so when we took those two marbles, we took two different marbles. That's a compound event, not one that is simple or independent. Okay, and determined is just that, like, probability, that possibility. Okay. Shh, I'm in the middle of teaching and recording. All right, we're looking right here at probability. The probability of event is a number between 0 and 1 that indicates the likelihood that event will occur. So 0, the event will not occur at all. 1/2, event is equally likely to occur as not. 1, event will be certain to occur. Okay? There are two types of probability, theoretical and experimental. Okay, so I would like you to have that all down, that all probabilities should be between 0 and 1. Because you can't have if you get a probability of 2, or if you get a probability of 15, that is not correct. It should be between 0 and 1. So it's like 0, 1/3, 1/2, 5/16, any of those. And that we've got two types of probability, theoretical and experimental. So you should be writing this down. That their probability is between 0 and 1, and that there are two types of probability, theoretical and experimental. Yes? Not really. I would move closer. I can't make this bigger. Shh. I have to record it, so it has to fit in this area, so I can't do it. Shh. So I would move closer if you can't see. Okay. Theoretical. So there's two things on this slide that I want you to write down. Probabilities between 0 and 1. And there are two types of probability, experimental and theoretical. And experimental.
What are the two types?
Theoretical and experimental. Okay, shh, stop talking, gentlemen.
Theoretical.
And experimental, Josh. Okay, so theoretical and experimental probability. Theoretical probability of an event is often simply called the probability of the event. Probability A, number of outcomes in A, total number of outcomes. So in this, you think of this as all your possible outcomes is all those dots in there. That circle is the outcomes of events A. So you have 9 little dots, so it'd be 4 out of 9. All of those dots are your sample space. Okay? You can express a probability in a fraction, a decimal, or a percent. For example, 1/2, 0.5, or 50%. 1/2, 0.5, or 50%. As a fraction, decimal, or percentage. Okay, so we think of theoretical probability as the probability of the event. We have the number of outcomes over the total number of outcomes. Total number of outcomes in A over the total outcomes. And that it can be written as a decimal, fraction, or percentage. Okay, moving on to the next slide. You got a 6-sided die whose sides are numbered from 1 to 6. So that's your sample space, right there. Find the probability of rolling a 4. Okay? How do we know how many possibilities is there here to roll a 4? We've got 6 different outcomes. How many of them say 4 on them? 1. And how many are there altogether? So it's 1 out of 6. The number in A over the total possibilities. So that's how we're getting 1 out of 6 here. Okay, here's another one. You roll a 6-sided die whose sides are numbered from 1 through 6. Find the probability of rolling an odd numbered die. How many possible ones are odd? Right? Because 5 is odd, 3 is odd, and 1 is odd. The rest are evens. So it's 3 out of 6, which can be reduced to 1 half, which could also be written as what? 0.5 or 50%. Does that make sense, these examples? How many possible outcomes? So we have 1, 2, 3, 4, 5, 6, right? For a die. If we're talking about 1 die. So if we're talking about 2 dice, then it wouldn't be. No, it would be 36. So yeah, because you could have a 1 and a 2, a 1 and a 3, a 1 and a 4. You know what I'm saying? Okay, let's do another one. All right. You roll a 6-sided die. Find the probability of rolling a number less than 7. How many of those are less than 7? Yeah, which would be 1. So if I'm rolling a dice, I'm 100% guaranteed to roll a number less than 7. I think that would be a great trick to play on like a sibling or a friend. Hey, I'll bet you that when I roll this dice, I'm going to get less than 7. I mean, you're 100% guaranteed to win, right?
Yeah, but then they're going to catch on.
Oh, it's only going to work once. Okay. So, I've got some dice. We can actually try some of those. Well, it's probability, so it's math. Okay. All right, I need you guys to pay attention again up here. Shh. Okay, we're going to look at cards now. All right. There are 52 cards in a deck. So what are my chances of picking an ace? How many aces are there in a deck of cards? How many? 4. And how many cards are there?
52.
Okay, so let's look. We're breaking this down now. Okay. So there are 4 cards in a deck. There are 4 aces in a deck out of 52. So I have 4 divided by 52, which is the same as 1 out of 13. So you have a 1 out of 13 chance of getting an ace. Yep, you're reducing. And you have to know the total is 52, and you have to know there are 4 aces in the deck, right? This is a great way, like, if you're playing blackjack, okay? If blackjack is you're trying to hit a certain amount. Yeah, you're trying to hit 21 points.
You know what the odds are of getting a royal flush? Isn't it like
We can figure it out.
It's something crazy.
Okay. So, okay. So should we try, I don't have another one up here, but shh, let's talk about that real quick. So, if I've got 52 cards, right? All right, I want to know the chances of getting a number. So I'm going to write this down. What are the chances on getting an even number? So this is a little more complicated. So first of all, how many cards are in my deck still? 52. Okay, let's talk about the even numbers. We've got 2, 4,
Queens is even.
6, 8, 10. So that's a good question. Are we counting queens as even? Because this doesn't say anything about face cards. So let's just say we're talking about numbers. We'll say no face cards.
Well, if there were face cards, it'd be easier. You could just do it for 20.
Okay, so Abby asked a question. She's like, there's 4 of each, right? Okay, so we can't use aces are considered a face card, kind of. So I've got 4 2s, 4 4s, 4 6s, 4 8s, and 4 10s, right? So how many is that altogether?
20.
So 4 times 5 is 20, so that's 20 out of 52. And can we reduce that? It's going to be 10 out of
Over 21.
26,
Or 27.
right? Because 26.
Oh,
But
yeah,
that can be
yeah.
reduced more, and that's 5 out of 13. Okay, should we try another one? Yeah. Okay. So we've got 52 cards. What do you want to do? What are your chances of getting you want to do a face card? Face card. Okay, so what, are we counting ace as a face card, yes or no? Okay, so we've got aces, jacks, queens,
Joker.
kings. Joker is not part of the 52, because if it was a joker, we'd have to do it out of 54. So, how many aces are there? How many jacks? How many queens? How many kings?
60.
Okay, so we got 16 out of 52, and we can reduce that to?
8 over 1.
If we can do 8 over 26, but then we can reduce it again to 4 out of 13, right? So you've got a little bit more higher chance to get an even card than you do a face card.
But not much.
Should we try a real easy one? What are the chances of pulling a spade?
1 out of 13.
No, he's not. Okay, so there are 13 out of 52, which reduces to 1 out of 13. Because 13 goes into 13, oh no, this is not true. 1 out of 4. Because 13 goes into 52 one time, so 1 out of 4.
Oh,
So
okay.
how many spades are in a deck of 52 cards? 13. Because they're all even, right? Or if we know we've got spades, hearts, diamonds, and clubs, and they're even, right? We have this even number of them. So this is 1/4 of the total, right? So we could think of it that way too. There are 4 different suits, 1 out of 4, or 13 out of 52. How are we feeling? I'm going to give you some more different kinds of this for your homework. So, Kayla, can you move the scissors aside and hand me one of those? Actually, let's hand it over. Okay, so I'm giving you a bunch of simple probability to do for homework. You're going to do the front and the back side of this. Remember, everything you're saying in class is picked up on my recording, gentlemen that are talking in the front for some reason. Yes. James, what is your question, sir? What's your question?
No, I'm kidding.
Oh, yeah, right past. I thought you said you had a question. Okay. Hold on, I'm still recording. I'm still going over this right now. I want to make sure everybody understands their homework before we do anything else. So you should not be talking right now. You should be listening. Okay, this side says, when the boy tire maker married the girl tire maker, what did he say? And you're just going through here. Suppose you roll a regular dice. We got a dice, spinner, marbles, all this. When you get your correct answer, you put the letter down here. Okay? The back is, what did the king's birthday celebration last so long? This is a little bit more confusing. We're going to do one of these we're going to do number 1 first. So it said, what's the probability of getting red? How many different options do I have? 5, and how many of them are red? So it should be 1 out of 5. Okay, so I go up here to this key code. I see 1/5 is T. So now I'm going to go number 1. I'm going to put a T. Okay, and it's going to answer, why did the king's birthday last so long? Okay, so you're going to do the front and back. This is your homework. You guys have almost half an hour to get it done. So you've got lots and lots of time to work on this. You should try to get this done in class today.